So hello everyone, my name is Philip and today we're going to talk about pH determination. Now as you may know, pH determination is a commonly used analysis inside the lab. To start things off, let's talk about what is pH. pH is actually a numeric scale used to specify the acidity or the alkalinity of an aqueous solution. It is roughly the negative of the log to base 10 of the concentration measured in units of moles per liter of hydrogen ions, or H+. But more precisely, it is actually the negative of the log to base 10 of the activity of the hydrogen ion. The other thing that you should be aware of is this measurement is temperature dependent. So depending on the temperature in which you carry out the measurement at, the pH value you're going to get is going to change. So this is something that you should be aware of. Now when you look at the pH scale, it starts from 0 all the way up to 14. Okay, so normally when you're looking at acids, you should be looking at small pH numbers, so in the range of less than 7. When you're over 7, then you're looking at the alkalis, or the basic range of the chemical range, okay, all the way up to 14. And if you're dealing with a pH of 7, that it means it's neutral. So for example, water is neutral, so water is usually pH of 7. Now let's talk about the methods of pH determination. The two common methods that we usually see is using the pH paper and also the pH meter, or in other words is the potentiometric means of determining the pH. Let's talk about pH paper because this one is the easiest and most straightforward one. On your left, you'll see a picture of someone using a pH paper and putting the pH paper into the solution that is being tested. Afterwards, all you have to do is you just take out the pH paper. It should change color and you compare that color to the chart that is provided with the pH paper. And once you look at the color, then you'll know what is the pH. Now the main advantage of this method is it's very easy to do, very convenient. You just stick a paper into the solution, boom, and you already have a result. The main drawback of this method is it's not so accurate. Sometimes when you look at the color, it's not immediately clear which pH number it should be, because sometimes there might be some, it could overlap in terms of color. Sometimes it might seem like a pH 7, pH 8, might be hard to distinguish. And also the accuracy as well, okay? As you can see on the pH chart, it's basically just talking about pH 1, 2, 3, 4, 5. It's not very precise and not very accurate. Now, the other method is using the pH meter. In this case, it's actually a potentiometric means of determining the pH. So basically what you do, you stick a probe, an electrode if you will, and you put it inside the solution. What it does is your pH meter will measure the amount of voltage inside your solution, and then based on that it will generate a pH reading. So it's, in terms of usage, is also pretty straightforward. All you have to do, you stick the electrode or the probe into the sample and you take your reading. Now as always, be sure that when you're doing any analysis, make sure your sample is well mixed before taking the reading, because if it's not well mixed, then you might have some inaccuracies when you're taking the pH of your sample. The other thing to be aware of is in terms of the pH meter, it's one of the main advantage is it's more accurate. Okay, you'll get more precise readings rather than just knowing it's a pH 4. It might be more detailed, it might be pH 4 point something something something. Okay, so the accuracy is better. The other thing to be aware of is make sure that your electrode, you're using the proper electrode, you maintain it properly, then it should give very accurate results. Now the main drawback is you have to do more stuff. Okay, you have to calibrate the pH meter each time. Normally you should calibrate at least once per day, so that can be a bit annoying. and also it's slightly more pricier, okay, because having a pH meter is obviously more expensive than having a pH paper. Now, speaking of the pH meter, one thing that we always have to do is the calibration, as I mentioned before. Now, what is the purpose of calibration? Basically, you want to take a series of pH buffers with known pH values, and you're gonna use these buffers to calibrate a line, okay, so that you can generate a line that corresponds a given voltage versus the pH reading. Now, again, like I said, having a pH meter is slightly pricier because number one, you have to pay for the pH meter itself, and number two, you actually have to purchase these pH buffers, which can be quite pricey because they have been standardized. They know exactly what is the pH value and also the appropriate conductivity of the pH buffer as well. So this is why pH meter is more accurate as well. Now, what we usually do is, if you're doing a pH calibration, you should have at least, at the very minimum, at least 2 pH buffers being used. But if you want more accuracy, if you want a wider range, then you should probably use more. Okay, so I would recommend at least 3 to 4 pH buffers over the range of your application. Now, here's one example of a pH calibration chart. Now, in this particular graph, it shows 2 buffers being used, one at pH 7 and one at pH 10. So as you can see, there's a direct correlation between the conductivity or the voltage that is being measured by the probe versus the pH reading. So in our case, pH 7 corresponds to 0.0 millivolts, and pH 10 corresponds to negative 177.5 millivolts. Now, of course, these are ideal values, but in reality, there might be some slight deviations, which is to be expected. Now, as I mentioned before, whenever you do a pH calibration, pay attention to the temperature that you're using, because pH determination is sensitive to the temperature. So if you're doing a measurement at a different temperature range, then you should probably carry out that calibration at that specific temperature range, because it will change with temperature. Now, as I mentioned before, in this particular case, you're only using 2 buffers, so a buffer of pH 7 and a buffer of pH 10. So ideally, if you're testing a sample between this range, then that should be perfect. Okay. For example, if your sample you're expecting to be in the pH range of about 8, then if you use this sort of calibration, then it shouldn't be a problem because it falls well within the calibration curve. However, if you want to test a pH, let's say pH 5, in that particular case, you should add on more pH buffers, so additional calibration points, so that the calibration curve that you're using covers your application range, or the range at which you are testing your sample. So as I mentioned before, if you want a larger range, then you're going to need to get more pH buffers and then calibrate your pH meter that way. And other thing to be aware of is make sure when you're choosing the pH buffers, okay, make sure it covers your application range. Okay, so what I usually recommend is, if you're not sure what the pH, what is the pH of your sample, then you should probably go for a larger pH calibration range so that you can have better coverage. Another thing to be aware of is make sure if you're using pH buffers, make sure that the pH does not differ by more than 3 pH units, okay? Because if you're using, for example, if you're using a pH buffer 4 and you're using a second buffer at pH 10, you're probably gonna get, if you're only using these 2 buffers, you're probably gonna get inaccuracies, okay, with your pH curve, okay? Because the middle part of the pH range might not be so accurate, and the calibration curve that you generate will also be not accurate. So then when you actually go and test your sample, that pH result will be inaccurate as well. So that's something to be aware of. One other thing to note is after you do your pH calibration, you should always do a verification using the same buffers to confirm that the calibration curve is generating reasonable results. Now, the whole point of doing this is you already know the given pH of that buffer, whatever buffers you're using. You just stick it into the pH meter, take a reading. If it falls within a reasonable range, then you'll take comfort in noting that the pH meter was calibrated properly. So that's an introduction to pH determination. Thank you for listening.